So today we are going to study about dynamic memory allocation. So a problem with many simple programs such as those written so far is that they tend to use fixed size arrays which may or may not be big enough. One minute. Okay, we already studied about the arrays. So there we declared array something like int a of 100 or someone a of 50 or a of 10. But in most of the cases we didn't use all these 100 cells. We used only 5 cells or we used only some 10 cells. So that means we are wasting some 90 cells or 90 memory spaces to store some integer. So suppose I am declaring some array with int a of 5, and in this array if I am trying to store some 10 element, it is also not possible. So that's the problem with fixed size arrays. So which may or may not be big enough. Sometimes it will be too big. Sometimes it is small enough to satisfy our requirements. So that's the problem with fixed size arrays. There are more problems of using arrays. There are more problems of using arrays. Firstly, there is a possibility of overflow since C does not check array bounds. So if there is an array of a of 5 and if I am trying to store 10 elements, overflow will happen. That is called overflow. Secondly, there is wastage of space. If an array of 100 elements is declared and a few are used, it leads to wastage of memory space. So this is what we already discussed. Those are other two problems of using array. So how can the restriction of fixed size arrays be avoided? So we have two problems. Somehow we have to solve it. The answer is dynamic memory allocation. It is the required memory that is allocated at runtime or at the time of execution. So when we implemented some C program, first we declare some array of size 100. Then I read a value n to get the number of elements. Then I read n to get number of elements. So actual requirement is only n. Actual requirement is only n. So what I require is an array of size n. But what I have is already a big array. So this a of 100 is known at the time of compilation. Because at the time of compilation itself, the program knows the size of the array is 100. The size of the array is 100. The value of n is known only during execution. Only after execution, we are giving value of n. So here, dynamic memory allocation allows allocate memory for some n elements. So it is the required memory that is allocated at runtime. The required memory is actually n. So that is known only at the runtime. So if we allocate some n size, that we can say it as dynamic memory allocation. Dynamic means changing. Suppose I am running the program in another instance, I will give 10. So the size of the array or the memory allocated will be of size 10. In another occasion it will be 20. So 20 space will be allocated. That's why it is dynamic. It is changing. But if in case of int a of 100, every time the size will be 100. But we are using only some 10-20 spaces. Dynamic memory allocation is a way to defer the decision of how much memory is necessary until the program is actually running, or give back memory that the program no longer needs. So I hope you already understood what is dynamic memory allocation. One more thing is possible. So after doing our required operation, we can give that memory back. That means we can free that memory. It can be used for some other programs. So that option is also available in dynamic memory allocation. So it helps us to allocate memory based on our need, and also after the usage we can free that memory or we can give that memory back to the computer. So I hope you got some idea about dynamic memory allocation. So to allocate memory dynamically, we have some library functions. They are malloc, calloc, realloc, and free. These functions are defined in std_lib.h header file. So these already studied about header files and library functions. This is the header file, and these 4 library functions are included within this header file. So we will look one by one. This is read as malloc, calloc, realloc, and free. Don't read it as malloc, calloc, something like that. Always read malloc, calloc, realloc, and free. So we will look into detail everything. Malloc or memory allocation method in C is used to dynamically allocate a single large block of memory with the specified size. It returns a pointer of type void. Which can be cast into a pointer of any form. So I hope you remember the word void and cast. So what is the specialty of void pointer? Void pointer can hold address of any type. Cast means explicitly changing data type of one variable or explicitly changing data type of one data item. So if you remember typecasting and void data type, it is very easy to understand. It does not initialize memory at execution time, so that it has initializes each block with default garbage value initially. So malloc is to allocate a single large block of memory. So some large block of memory is allocated to our program. So initially those large block will be filled with some garbage values. Garbage values means some meaningless values or some unwanted values. If space is insufficient, allocation fails. So if in the RAM that space is not available, that allocation fails and returns a null pointer. Null pointer means it doesn't have any address. So if space is insufficient means, suppose I have a RAM of some size. Suppose half the size will be filled with some other data and some half is available. Suppose I am requesting a block which is greater than this half size. That means the sufficient free space is insufficient. The required free space is insufficient. When it is insufficient, what happens? The allocation fails and returns a null pointer. So here is the syntax. PTR means pointer. Cast type, that will be easily understand when we see the example. malloc byte size. So here I told you it allocates a single large block of memory. So how much size we need or how much bytes we need, that is given here. How many bytes are required are given here. Okay. Suppose I want to store 5 integer values. You just imagine. Suppose I want to store 5 integer values and each integer is of 4 bytes. Alex?
Yes, sir.
So 5 integers, each Each integer need 4 bytes. So what will be the total size?
20 bytes.
20 bytes will be the total size. Very good. So we need a large block of memory with 20 bytes. Okay. So you just look at here 5 star size of int. Why I have written size of int? Because I have to store 5 integers. Why I write size of int? Because based on the computer the size of will change. Some computer need 4 bytes, some computer needs only 2 bytes. So if I can't give 4 star, 5 star 4 here because in some other computer it will not work. So that's why I have written here size of int. So size of function we already studied. It will return the number of bytes required to store an integer. So 5 star 4. So 20 bytes will be allocated. Okay. Here cast type. So I have got a large memory, but what type of data I have to store in that memory? Sometime I have to store some character data. Sometime I have to store some integer data. Another occasion I have to store some floating point data. That is written here. So if I want to store integer, I will write int star cast type. So what happens here? 20 bytes are allocated, and these bytes can store some integer values, and I have a pointer here. Pointer can hold some address. So you just imagine some 20 bytes are allocated with address values from 1001 to 1020. So in PTR what will be stored? In PTR this 1001 will be stored because that is the address of first byte. So what will be the type of the pointer? Here I told you it returns a pointer of type void. That means this block or this portion returns an integer of type void. It returns an address which can be stored in any type of pointer which can be casted into a pointer of any form. Okay, here I applied typecasting. So this address, this void address or this pointer with void type is typecasted to integer type. Int star means pointer of integer type. Because in syntax itself, cast type followed by a star. Since I have to cast it into integer type, I have given int here. So this 1000 and end result is 1001 will be stored to PTR. So PTR must be an integer pointer. So it is integer pointer. Okay. Here some points are written. Since the size of int is 4 bytes, this statement will allocate 20 bytes of memory. 5 star 4 is 20. And the pointer PTR holds the address of first byte in the allocated memory. So here 1001 will be stored in PTR. So it is similar to integer array of size 5. Advait,
Yes, sir.
here PTR is 1000 plus 1. What will be PTR plus 1?
1005 only, sir.
Okay, very good. 1005. Okay. Why? Because PTR is 1000. It is of type integer. We already studied pointer arithmetic. If we add 1 to a pointer variable of type integer, the size of will be added. Here size of is 4. So 1001 plus 4 is 1005. Rohit PB. Rohit,
So,
what will be PTR plus 4? Rohit, what is PTR plus 4? Saket Kumar,
Yes, sir.
sir, 1017.
okay, okay, Rohit, 1017, because PTR plus 4 means PTR plus 4 into size of integer. PTR is 1001 plus 4 into size of integer means 16. 4 into 4 is 16, so 1001 plus 1017 is 16. Is it clear? If it is clear, please respond with a clear message. Sham Santosh,
Yes, sir.
മനസ്സിലായോ?
Monthly.
Okay. Next, I will say one question. Suppose in examination, some question may be asked. Write a program to sort some elements without using array. Without using array. Sometime you may ask some other question. You have to apply binary search without using array. Otherwise, you can ask store and read some n elements without using array. So, in that type of question, you have to include this. You have to write the program based on dynamic memory allocation. Dynamic memory allocation. So, you will see on program. It's a very simple one. So last class we studied about a program to read and print an array with the help of pointer notation. With the help of pointer notation. There we studied ampersand a of I can be replaced with a plus I, and a of I can be replaced with star of a plus I. So here I am giving some 100. What's the meaning? I have an array mark of 100 students. I have an array mark which can store marks of 100 students. But I need only to store only some 37 students or some 40 students. So remaining are wastage of memory. To avoid that, we are using some dynamic memory allocation techniques. Okay. Here you just look at the right hand side. Is it visible? Is the right hand side visible? Please respond.
Yes, sir.
Okay. Here I have a PTR. So PTR is similar to array name. PTR is similar to array name. We already studied. If I have any array A is the array name, and A contains address of the first cell. Similar to that, here 1001 is stored in PTR. It is a pointer. It is an integer pointer. Here in our earlier program, the array name is mark. So I am making some modifications. Watch it carefully. Instead of mark of 100, I am giving star mark. Now mark is a pointer which can hold integer address. Next, n and I are there. Printf enter number of students. Suppose I entered 5. Any doubt? Harsha Shivu, please mute your mic. Okay. So I have 5 students. So since it is an integer, I need 4 into 5 bytes. That is 20 bytes. So I am going to include on statement. Listen carefully. Here I am writing mark equal to, that means this pointer, integer pointer. Here our pointer name is mark. Cast type. Here I need an integer array. So int star. Then malloc. How many bytes are required? N, because n into how many bytes are required? N into size of int. Size of int. So n means 5, size of int means 4. 4 bytes will be allocated. It will return a void pointer. I convert that void pointer into int star. That means I point it in an integer type. Okay. So remaining programs, now change in the remaining part. So I am executing the program. Some error is there because I missed the semicolon here. Okay. Entering number of students, I am entering some 6. Marks, I am entering some random values 1, 2, 3, 4, 5, 6. So the entered marks are 1, 2, 3, 4, 5, 6. So only change is that size I removed, put a star, then I wrote this malloc statement. Remaining all are same. Remaining things are same. If this program is clear, please type clear in the chat box.
Sir, can you explain once star mark?
Which one? In line number 3.
First, yes, sir.
Okay. So here, come back to our slide. Okay. Here, malloc returns a pointer of type void. So this portion will return a pointer of type void, which can be cast into a pointer of any form that I have converted or forcefully converted into integer pointer. So now the void pointer changed to integer pointer that I am storing into PTR. So PTR can hold an address of type int. So I have to declare this pointer as int. Somewhere before this statement, I have to declare something like int star PTR. Okay. Coming back to our program, here I have written this statement. Here instead of PTR, I have written mark. So mark must be an integer pointer. So I have written star mark. So what will happen here? 20 bytes is allocated. Address of first byte will be stored to that pointer. Address of first byte is allocated to pointer. Since it is an integer pointer, during integer addition or addition with a constant, it will add 4. If I write PTR plus 1, it will add 4. If I write PTR plus 2, it will add 8. If I write PTR plus 3, it will add 12. Is it clear now?
Yes, sir.
Who asked that out? What's your name? Okay, Saksham says. Okay, is it clear, Saksham?
Yes.
Okay. So malloc is finished. We are going to next one, calloc. So malloc is memory allocation. Calloc is contiguous allocation. That means continuous allocation. Calloc or contiguous allocation method in C is used to dynamically allocate the specified number of blocks of memory of specified type. Earlier, a large block of memory is allocated. Here what happens? Number of blocks will be allocated. More than one blocks will be allocated of specified type. Sorry, not of specified type. It is of specified size. It initializes each block with a default value 0. Earlier, default values are garbage values, some random values or some meaningless values. Here, each block with a default value 0. It has two parameters, number of blocks and size of each block. Earlier, I have only one parameter, byte size, because it allocates a single large block of memory. You have to give the size of that large block. Here, number of blocks and size of each block. Here also, ptr equal to typecast star clog n comma element size. Here n is the number of elements and element size is size of each element. The two parameters are there. Number of blocks, specified size. So here first is number of blocks, element size. And one more thing, it is contiguous. So these blocks will be allocated in increasing location or in nearby location or in successive location or in continuous location. Okay. So here n is the number of elements and element size is of size. Element size is the size of each element. Suppose I want to create an array of something similar to int a of 5. Suppose I am executing clog. So here I will make 5 blocks, each of size 4. So here also 5 into 4 memory is allocated. Then the end result is same as malloc. So here I will give 5. Since it is an integer array, here I will give size of int. So example, ptr equal to end star clog 5 comma size of int. This statement allocates contiguous space in memory for 5 elements, each with size of int or 4 bytes. The pointer address holds the address of first block. The concept is same as malloc, only difference is in the syntax. There a large block of memory is used, here small blocks of memory with required size. Small number of blocks with required size. Is it clear? If it is clear, please respond with a clear message. Here I will edit the same program. Tanush J.
Sir.
Suppose earlier I have read a pointer and I read an array and I printed that array using malloc. Suppose I am using clog, what will be the differences?
Sir, net cut and any preview.
Can you repeat again?
Sir, net cut and type.
Okay. Fida Sakuda. So what are the changes I have to make in this program if I use clog? So in which line I have to make the change? Okay, line number 6. Instead of malloc, I have to use clog. So here it is n comma element size. So just remove the star to comma. So I am executing the program. 5 students. 1, 2, 3, 4, 5. So 5 marks are printed. So you have to make the necessary changes based on the question. If it is something to sort, you have to make that change. Okay. So I will take one program for sorting, and also I will show you the changes. So I will take bubble sort. So you have to say the changes. So I will call one by one. Ankur Jaiswal. Ankur Jaiswal. So he is not responding. Alex.
Yes, sir.
So what is the change I have to make at line number 29?
Sir, into star mark domain.
Okay, 100 has to be removed in the star A. Very good. So now changing line number 30, 31, 32, 33, 34. I have some change. Advait. Advait. What is the change I have to make at line number 34?
A plus I, sir.
Okay, A plus I. Very good. Let me change it to A plus I. No change in line number 35. No change in line number 36. Okay. Anu Fasmin.
Yes,
What
sir.
is the change required at line number 1? Here there is no array, so we can't give box bracket.
Yes, sir. Box bracket removal.
Okay, removed box bracket. Instead of that, what I have to give?
Star.
Very good. Here also I have removed box bracket. I give a star. Line number 3. Debug. Debug.
Yes, sir.
What is the change I have to make at line number 3?
Line number in the star.
Okay, very good. Start. Good afternoon, I already called you. Gogul Krishnan. Gogul Krishnan. Mayankiraj.
Yes, sir.
Is there any change in line number 6?
No, sir.
7?
No, sir.
8?
No, sir.
9?
No, sir.
What about 10?
A plus J.
Not A plus J, star A plus J. A of J is
Yes, sir. Star A plus.
A plus J. Here, what about A of J plus 1? Star of A plus
A
J
plus
plus
J plus
1. Rohit PB. Rohit PB. Saksham Setu.
Yes, sir.
What's the change I have to make in line number 12?
T equal to star
A plus J.
A plus
Star A plus J. So similarly it will be star A plus J plus 1. That's similarly it is same as star A plus J plus 1. Here also I have changed to. Please respond.
Yes, sir.
Right, lost the net connection. Okay. Is it visible? Is the screen visible?
Yes, sir.
Okay. So here I will change to star a plus I. I am executing the program, giving some 5 elements.
Sir, in line number 13,
Line number 30.
star A plus J.
Okay. Let it be like that, A of J. We will check whether it works or not. Anyway, I have to change, but it will work. So it is sorted. So even if you write A of J, it is not a problem. But for the examination, when it is asked without using array, it is good if you avoid all the array notations. A plus J. So even if you didn't change, because the meaning of A of J is same as star A plus J, and also J of A that we already studied earlier. 55, 56, 44, 22, 33, 7. So actually here I ended 6 elements, that's why 11 is not in the output. Okay. So here it is worked, even though if you notice here, even though I didn't include this CLOC or envelope, it worked, but in all cases it will not work. So here there is no envelope or CLOC, still it worked, but we can't guarantee it will work every time. So I am including that here. I am just including that CLOC statement. I am just copying it from here. Here I have to write A equal to combining and executing. Can either use envelope or CLOC. Both will work. 33, 44, 45. So it is alt 11, 22, 33, 44 and 55. So any doubt in envelope and CLOC?
No, sir.
So more exercise. Write a program to read and display metrics without using arrays. So we studied how to construct an one-dimensional array with the help of malloc. So here actually I have to convert a two-dimensional array. So here I have an A. We already studied the internal architecture of two-dimensional array. We are going to construct something similar to that. So in the internal structure of two-dimensional array, we have a one-dimensional pointer array. Varsha Shibu, what will be the content of this location? So here I have an array. What will be the content here?
A0.
It will be A0. What will be the content?
Address
Address of
A of 0.
A of 00. Address of A of 00. So here some address will be there. That address will be stored here. Here some address will be there. That address will be stored here. So this is A of 00. This one also studied in the previous class. That address of A of 00 will be stored here. Okay. So one more thing, when we are going to implement this program, we are written matrix program starting from A of 1 1 only. We didn't use any A of 00 to match with our mathematical notation, we have used only A of 1, 1. So earlier I created some arrays. Actually, I didn't use the first row. I didn't use the first row. And I didn't use the first column. I didn't use the first column. So earlier I allocated something like A of 50, 50. A of 50, 50. But if I give some 3 cross 3 output, I used only some 9 cells. Remaining cells are unused. Remaining cells are unused. So here, since I am using dynamic memory allocation, I can create array of size 9. I can create a 2-dimensional array of size 9, 3 cross 3. But since we studied the notations from 1, 1, if I want to create an array of 3, 3, actual array I want to create is 4 star 4. 4 star 4, because I am not using the first row and also first column. So to match this notation only I am using that. So if I want to use some 2 cross 3 matrix, I want to create some locations to store 3 cross 4 matrix. In that, first column and first row I am not using. So keep those things in mind. Okay. The first step is to create this pointer array. Pointer array means an array which can hold some address values. So here this will store the address of first cell. This will store address of this row's first cell. So this one is already familiar to you. This A stores address of this cell. Conceptually, it will store address of this cell. Never think in this for the value of A. Never compare with the earlier thing what we have studied. Here you just think like address of this cell will be stored in A. Address of this cell will be stored in A. So this A can be treated as a double pointer, because A is actually contains some address. That location contains another address, and the address of that location actually contains the actual data. So this A can be treated as a double pointer. So we already studied the concept of double pointer. A contains address of this cell, and this cell contains address of this first cell of array. So A is a double pointer. So its type will be star star A. It will be a pointer array. Anyway, I will explain the program with help of an example. At that time it will be clear. Read print matrix in pointer notation. So here instead of A of 50, 50, you have to give star star A. It is a double pointer. Here what I am doing here is, first I am creating this pointer array. Sound is breaking. Is it breaking to everyone?
No, sir.
Okay. So first thing is I have to create this pointer array. So what will be the size? But how many elements are there in this pointer array? Here I have 5 elements. 5 element means it will be same as number of rows. So anyway, based on our previous experience, we are just leaving the first column and first row. So I'm using malloc actually. or CLOC, anything. This time using MLOC. MLOC number of rows. So here it is R. Because I am leaving the first row, I am using R plus 1 star size of how many bytes are allocated. Earlier I have written size of int. It is a pointer array. So what I have to write? Size of, not int star. Since this is a pointer array which holds the address of some integer values, I am writing it as int star. Then again malloc. Malloc, it is written as cast type star. So here what I am writing is cast type star. Already there is a star. In left of that, where I am casting this, I am casting this to another pointer, but it is a double pointer. So I am giving int star. So you just, in shortcut, you just remember, if I use int, here also you have to use int star. Here if you use int star, here you have to use int star star. So A equal to int star star envelope of R plus 1 star size of int star. It creates this pointer array. Next I am using a for loop. Listen carefully, I will explain it later. I equal to 1 or I less than or equal to R I plus plus A of 0 equal to not A of 0, A of I. So anyway, I am not storing anything here. So I am not going to create this array. Here I want to create an array. Here I want to create a block which is similar to some array. So where it is stored, where the address of first cell is stored. So you just compare with the earlier programs. I am creating a block of memory. First address I am storing to this cell. So A of I, here I equal to 1. So A of 1 equal to, here you can write malloc. Okay. Here how many cells are there? Here C number of cells has to be there. Here the number of cells means number of columns. I need C cells. Since I am leaving the first cell empty, I am declaring it as C plus 1. C plus 1 C plus 1 star size of, here is integer array, so I am giving int. So I had to cast it to int star. So during the first iteration, this cell will be created and this address will be allocated to A of 1. In second iteration, this entire block will be created and it will be stored to this cell. Similarly, at the end of the for loop, these much things are created and its address will be allocated to the corresponding cells. Now I created something similar to two-dimensional array using dynamic memory allocation. Now I am executing the program. And their number of rows and columns I am giving 2, 3. So 6 elements will be there. 2 rows 1, 2, 3, 4, 5, 6. So it is printed in two rows 1, 2, 3, 4, 5, 6. Is it clear? Is it clear? Is the program clear? Please respond. Some confusion will be there. If you have any confusion, please ask. I am ready to explain it. Anybody need any clarifications? If it is clear, please type a clear in the chat box. So what's the doubt? Please ask.
Sir, can you explain the for loop?
Which?
Line number 7.
Line number?
7.
Line number 7. Okay. So line number 6 is the line number 6 clear to everyone? Anybody have any doubt in line number 6? Line number 6.
Yes, sir.
Anybody have any doubt?
Voice is breaking, sir. Your voice is breaking.
Voice is breaking. So I am at college and the net is not stable. Is it breaking for everyone? Please respond. Is it breaking for everyone? Am I audible?
Yes.
Am I audible?
Now you're audible, sir.
Okay. So line number 6 is to create this pointer array. So here I am using r+1 because we are going to leave the first row without filling anything. Here I am using int star because it is a pointer array of type integer. Here int star is used because in the syntax itself it is cast type star. Here the data type is int star. So I am using int star here. So this much is created. So in each cell, and one more thing, 2D array is a array of one-dimensional array. That means the first cell contains an array. First row contains an array. Second row also contains an array. Third row also contains an array. Fourth row also contains some array. So I am going to create these arrays separately. These array-like structures separately using dynamic memory allocation. So here I have to create some 4 rows. So I am executing some statements 4 times. So I equal to 1, I less than or equal to r. So if I have to create 4 rows, r value will be 4. So this for loop will execute 4 times. So this statement is already written in the previous examples, or when we create array for bubble sort also we have written the same statement. Here I am giving C+1 because I need one extra space because I am leaving the first space empty. I am leaving the first cell empty. That's why I am giving C+1. And some address will be returned. So first time when the address is returned, I am storing it in A of 1. A of 0, no need to create this structure because we are not using the first row. Again in the second loop, some array like structure is created because this statement is executed, and that address, first address, will be stored in this cell. Similarly, in other 2 cells also, some array will be created and that address will be stored. Is it clear now? Who asked that doubt earlier?
Yes, sir.
Is it clear now?
Yes, sir.
So, if it is clear, please type clear in the chat box. So this question is asked multiple times in the previous years also. Write a program to add two matrices with the help of pointers, and also some to find transpose of a square matrix using pointers, multiplication of two matrices using pointers. So one thing is this much statements are to create a matrix A. Similar to that, you have to write same set of programs to create matrix B. There you have to replace this A with B. That's the only change. And one more thing, it is better not to use any matrix notations. So I am also changing A. Here it is A of I. Here it is A of I. I am changing it to star A plus I. So remaining things you can write, because you have to just replace that ampersand A of I with A plus I, and also you have to replace A of I with star A plus I. Remaining things are same. The only thing is you have to write these steps to create the matrix A and B, and also matrix C. Okay. So if you still have any doubt, I will publish the video. Anyway, if some voice break also happen, those voice breaks will not be in video, so you can watch it later. So still, if you will have a doubt, we will discuss it later. Okay, next is realloc. Realloc or reallocation method in C is used to dynamically change the memory allocation of a previously allocated memory. So for example, if I created to store some space to save some 5 elements, or to store some 5 elements, so after some time I want some more elements to store, I can add those spaces also. After storing 5 elements, if I want to store some 3 elements, some space to store 3 elements also can be attached along with these elements. That can be possible through realloc. So realloc or reallocation method in C is to dynamically change the memory allocation of a previously allocated memory. In other words, if the memory previously allocated with the help of malloc or calloc is insufficient, realloc can be used to dynamically reallocate memory. Reallocation of memory maintains the already present value. That means if I already stored some 5 elements, it will be already there in the memory, and new blocks will be initialized with the default garbage value. So syntax is ptr equal to realloc ptr comma new size. Earlier some size is allocated. You just imagine I have allocated some space to store some 5 elements, 5 integers, and it is stored to ptr. First address will be there in ptr. So if I want to allocate some 3 more spaces, so earlier the number of elements is n. Now what you have to write is the same ptr equal to realloc ptr comma it is n. Now suppose I want to add some m values, m more cells. You just write n plus m star. Yes, if it is an integer, you just write size of int. size of int. So this statement can be written for both calloc and malloc. If the earlier memory is allocated with malloc, you can write the same function. For calloc also, it will be the same. It will work properly. So anyway, I am not doing any examples here. So if you need some examples, you can refer on the internet. The examples are available. Otherwise, I will do some example and I will post it in the classroom later. So this is the syntax. New size means not give m only. M will actually reduce the size. If n is 5 and m is 3, if we give m, it will reduce the size. So you have to give the total space. So first 5 elements will be preserved. You can store the next 3 elements in the new allocated space. Any doubts in realloc? Any doubts? If it is clear, please type a clear message. So the response is a bit weak. Maybe it is you are a bit tired and also it is an afternoon session. So one more function is there, free. Free method in C is used to dynamically reallocate the memory. So I already told you, once we use that memory, we can deallocate that, or we can give it back to memory. So for that you can use free. Free method is in C is used to dynamically deallocate the memory. Memory allocated using malloc and calloc are not deallocated on their own. These are not deallocated on their own. Hence, free method is used whenever the dynamic memory allocation takes place. It helps to reduce wastage of memory by freeing it. Always it is a good practice to call free method after using malloc and calloc. Malloc and calloc. Syntax is just write free within bracket, write the pointer. For example, we already write this read and print matrix, read and print array using calloc. So after everything, we just call free ptr. So the result is not visible to user. It will free the allocated memory. So if you use malloc and calloc, it's a good practice to use the free at the end of the program. That's all about dynamic memory allocation. Definitely some question will be asked. So it is an important topic.